Right, so next up we're going to be looking at reduction formula in trigonometry. This is sort of the foundation of your grade 11 work, or at least the new thing that you're learning in grade 11. Very important because you'll also be using reduction formula from now on until matric. So make sure that you understand it. Pretty simple to do, but yeah, just make sure that you do understand the steps that go into reducing ratios properly. Okay. Reason being for this is because you know that we can plug in a few ratios that will output the same answers, right? Because of our trig waves, like let's look at sine, for example. You know, sine waves goes like that and it continues, it repeats. So if I input, let's say, this value over here, I will get that as an answer on my calculator. But also if I type in that value over there, I'll get the same thing as my answer. So basically, with reduction formula, what we're doing is we're making all of those angles that are all up here, reducing them to acute angles so that they're easier to work with. Right, so you don't really need to know that. You just need to know how to do it. Two rules I will tell you about is the 90 rule. You don't do the 270 anymore, but the same would work for 270, and the 180 and 360. So all you need to keep in mind is that whenever you have 90 plus or minus, you will change your ratio to its co-ratio. So basically, sine will change to cos, and cos will change to sine, because sine and cosine. Tan will change to cotangent, and cotangent to tan, but you try to avoid 90 with tangent. Right, 160 and 360, my ratio stays the same. Okay. So what is reduction formula? Anytime we find ourselves having 90, 180, or 360 plus minus anything, we can apply reduction formula and reduce that angle, okay, to an acute angle like I mentioned earlier. Very important though is that it must be in this order. You must have your 90 plus minus something, you must have your 180 plus minus something, and you must have your 360, sorry, not 270, plus minus something, right? Your angle obviously over there, the acute angle. Very important in order to do reduction formula. So we keep this in mind, the 90, 180, 360 rule, and we'll use that with my cos diagram. Cos diagram, obviously, A for all ratios are positive in my first quadrant. Second quadrant, we know sine is positive. Third quadrant, we know only tan is positive, right? Which means the other ratios are negative. And in my fourth quadrant, I know only cos is positive. So when we are applying reduction formula, I would like to say always do it in two steps. Meaning also make sure that you do it in this order, because often if you reduce in the wrong order, you'll get it wrong. So always check your sign first, whether it's going to be positive or negative, and then you check your ratio, meaning whether it stays the same or changes to its co-ratio. Okay, so that's literally all you need to know in terms of rules for reduction formula. So let's do a few as examples. Okay, so I'm going to erase this over here. Let's say, for example, I have sine 90 plus theta. All right, so what you're going to do is you're first going to check your sign. So you check your sign with this 90 plus. You know we have our cardinal points over there. So 90 plus will place us into the second quadrant. 90 plus obviously being between 90 and 180. So I say, is my ratio positive or negative in that quadrant? Sign is positive, so I know I have a positive answer. Next we check the ratio. So that's when we'll look at the rules. If it's 90, I know it changes to its co-ratio. So sine will change to cos. Therefore, my answer will be positive cos theta. Don't worry about the sign. If this was a negative, it's still theta, because this sign just tells us which ratio, which quadrant we'll find ourselves falling in. So my answer is cos theta. I'll give you another example. Let's say cos 180 minus theta. Right? What do we do first? First check my sign. So I look over here. 180 minus, which quadrant am I in? 180 minus will place me back in the second quadrant. So I say, is cos positive or negative in that quadrant? I know my cos is negative in that quadrant because only sine is positive in the second quadrant. Then I look at my ratio, 180. Does my ratio change or stay the same? 180, it stays the same. So my answer then is negative cos theta. You see how my negative doesn't come with it? It's just there to tell me which quadrant I'm in. That's how we'll solve reduction, or how we'll reduce angles. But it's not just limited to non-numerics. We can do this for numerical angles as well. Let's say, for example, I give you cos 225. No? Yes. Right? We know 225, or at least for reduction, 225 will obviously be in my third quadrant. So that will either be 180 plus or 270 minus. But since we don't know the 270 rule or don't learn it anymore, we will just use 180 plus because it needs to be one of these three for reduction formula. So I'm going to say cos 180 plus what? What gives me 225? Give you some time to work it out without touching the calculator. Well done. It's 45 degrees. Right. So what we also notice is that this 45 degrees is a special angle. Right? Which is important. That's why you need to know your special angles. Now we'll do the same thing. This now will be my theta. 180 plus, is it positive or negative? 180 plus places me in the third quadrant. We know cos is negative. Next, I look at the ratio. 180 stays the same. So my answer is negative cos 45. Because we know my special angles well enough, I will know that that just will change to 1 over root 2 for cos 45. Don't forget about the negative, so it carries down as well. Right, so final answer will be negative 1 over root 2. Guys, very important with this, please remember that cos is a ratio. So it changes to the fraction. It does not change to cos 1 over root 2. It becomes 1 over root 2. Okay, very important to remember. Stay tuned next for some examples on how to apply reduction formula and some tricks that usually catch some of you guys out. But thanks for watching.